Okay, welcome to question 5. It's another typical question. We'll start with A. You'll see quite a lot of these questions to do with polynomials, that they'll dress it up all nice and fancy. They're quite easy to do, really, if you just learn the system. If you go back through the exam papers, you'll see quite a lot of them and you'll quickly get the knack for it. So the first one, use the remainder theorem to find the remainder when p of x is divided by x minus 3 there. It's really simple. All you need to do, the remainder theorem, just means if you have an x minus 3 or an x minus 5 or whatever it is, then you take that 3, in this case a minus 3, change it into a plus 3 and put it in as your x there. You just change the sign of that number there, the x, and then whatever it is. You change the sign of it and put it in as your p of x there, and it'll give you what the remainder is. Okay, so let's do that now. We've got p of plus 3, there it is. P of plus 3 is equal to 3 to the power of 3 minus 2 times 3 squared plus 3. Next step, so that's equal to 27 minus 2 times 9 is minus 18 plus 3, and then the last step, that is equal to 12. So you just write in the bottom the remainder, there we go, remainder equals 12. There, that's your answer for the first one. Let's move on to the next one. Get rid of that. Okay, the next one, use the factor theorem. Now the factor theorem is pretty much just the remainder theorem, but backwards. You can think of it like that. So show that x plus 1 is a factor of p of x. So again, take that plus 1 there, change it into a minus 1, and put it into p of x. So if we do p of minus 1, then what we're doing is we're showing that it's a factor by saying if you put minus 1 in there, it should come out as 0, and if it does come out as 0, then it is a factor. Okay, you might be asked, is it a factor or not? Well, put it in. If it comes out as 0, it is a factor. In this case, they're saying show that it's a factor, so we already know it's going to come out as 0, but we'll do it anyway. You get minus 1 cubed minus 2 times minus 1 squared plus 3, which is equal to minus 1 minus 2 plus 3. Of course it is, it's equal to 0. And then you just say afterwards, therefore, you can use the little dots for therefore, x plus 1 is a factor. Is a factor. There you go. That's as difficult as those questions can get, really. Not very difficult at all. So, moving swiftly on to the next one, CI, and there you go, CI. Express p of x in the form blah blah blah. Okay, so this one, you just need to take out this factor, x plus 1, take that out of this original, I don't know, formula, original polynomial. Take it out of that. So some people will be able to do it straight away. I could never do it straight away, so I learned how to do it with long division. So you can go x plus 1, then divide by, go x cubed minus 2x plus 3. Even if you have, seen this before and you know how to do it, then stick with it anyway, because it'll show you just another way of doing it. So the first thing I'm going to do is take this x here. What do I need to times that by to get x cubed there? Well, it's x squared, so write down somewhere. I was going to write it on the top, but I haven't left enough space, so I'll write it in here, x squared. So then x squared times x is x cubed, x squared times 1 is plus x squared. I've written that wrong, x cubed in there, that's what that should be. Then simply take it away, x cubed minus x cubed is nothing. Then minus x, that's supposed to be x squared as well. A lot of mistakes going on here. Right, minus 2x squared, take away x squared is going to be minus 3x squared there, and then this 3 just moves down there like that. So you get plus 3. Plus 3 minus 0 is plus 3. Okay, next one. What do I need to times x by to get minus 3x squared? Well, it's going to be minus 3x. Minus 3x there. So we can write that in. Minus 3x squared. And then minus 3x times by 1 is minus 3x. Again, take them away. You end up with a 0 here. Then you're actually missing the x to the power of 1 term that should be in here. So kind of nothing, take away minus 3x is going to be plus 3x. And then again, 3 take away nothing, that's just going to come back round again as your plus 3. Haven't been leaving enough space. And then you can just finish it off by saying x times by 3 is going to give you 3x, so plus 3 gives you 3x plus 3. Look at that, it comes out as 0, of course it does. We knew it was going to from the first place. So there it is, that's your that's your B and that's your C from there. So you can just write down that the whole thing, all of this, x cubed minus 2x squared plus 3 is equal to x plus 1 times by x squared minus 3x plus 3. That's your answer for that question. Here we go then, let's get my space back. Right, last part. CII. Hence show that the equation P of x equals 0 has exactly one real root. Now this one's not actually that intuitive. It's just one of those questions that you see it enough times, you remember the answer for it eventually. What it's actually asking you is the one real root. The real root you found is this x plus 1. That's the real root that you found already. So it's saying that the roots that you might find in here, in this second part that you already found, they're not going to be real. So show that they're not real. The only way you can show that they're not real is by saying x squared minus 3x plus 3 equals 0. The only way to solve that is the quadratic equation, which of course you should probably know that by now, is x equals minus b plus or minus the square root of b squared minus 4ac, I think they might even give it to you in some of these exams, over 2a. Now the trick here, and it is a trick because you can go through and work it out and try and get there, but what you'll find is this, what's known as the discriminant in there, the discriminant, b squared minus 4ac, that will turn out, if you do it, we can do it now actually, why not? Let's just do that. It's going to be 9 minus 4 times 1 times 3, which is equal to minus 3. There you go. So you're going to get a minus 3, and obviously you can't root minus 3. There's no way of doing that. It's not a real number, if you think about it. So by saying there's only one real root is to say that the square root of minus 3 doesn't exist. So if you say that b squared minus 4ac is less than 0, so therefore there is only one real root.